Welcome to another video. In this problem, let's solve for all the possible values of x and y. And we consider this as equation 1, while this is equation 2. So this equation looks so complicated, but let's see how to simplify this problem. So if you have x minus y bracket, and so I open another bracket, if this is x squared plus xy plus y squared, everything equals to 0. And we should know that this is the difference of two cube. So, and it's an identity. And also if you have y square minus x square minus y square bracket x raised to power of 4 plus xy, let's say x square y square plus y raised to power of 4, and this is x raised to power 6 minus y raised to power of 6. So this is another identity. So what I will do here is, so we have x squared plus xy plus y squared, and this is equivalent to 13. So we just replace it here, and we multiply x minus y by 13. Then this is equals to x cube minus y cube. While for the second one, so we also do the same thing. So since it has been equivalent to something above, and we consider this as equation 3. So for this we have 91 bracket x raised to power of 2 minus y raised to power of 2. This equals to x raised to power of 6 minus y raised to power of 6. And this is equation 4. So let's divide these two equations. I mean the equation 3 and 4. So we are going to divide equation 4 by 3. Then we have 91 bracket x raised to power 2 minus y raised to power of 2 divided by 13 bracket x minus y, and this is equals to x raised to power 6 minus y raised to power of 6 divided by x raised to power 3 minus y raised to power of 3. So 13 in 91, that is 7 bracket. So y for this x square minus y square, so it can be reduced to x plus y, that is from difference of 2 square. This equals to, so by applying the same thing here, this also becomes x raised to power of 3 plus y raised to power of 3. Yeah. So it becomes x raised to power 3 plus y raised to power of 3. And this is gotten from, suppose this x raised to power of 6 is just like x raised to power 2 raised to power 3. So we can say apply difference of 2 square in that one. So, and this is more of x raised to power 3 plus y raised to power 3 bracket x raised to power 3 minus y raised to power of 3. So, and these two will cancel each other. Then we have this result. And also this, the sum of two cube can also be simplified as this. We have this equals to, then I can have this as x plus y bracket, open bracket, x square minus xy plus y square. So, and x plus y we cancelled. Then here we have 7 equals to x raised to power of 2 minus xy plus y square. And if I consider this as equation 5, so I think this is making sense. The next thing we are going to do here is, if we consider from equation 2, so which says, if you add equation 2 and 5 together, yeah. So let me add it so to make it simple. So we have 7 plus 13 equals 2. And what you have in equation 5 is x raised to the power of 2 minus xy plus y squared. While for the equation 2, so that one is x squared plus xy plus y squared. So this will cancel, and 13 plus 7 or 7 plus 13, that is 20, equals to, then x squared plus x squared, that is 2x squared, plus y squared plus y squared, that is 2y squared. And if I factorize out this, we are going to have 20. Then I will consider this one as another equation. Suppose I call it equation 6. So the next thing we are going to do here is, let's say I consider from equation 2, so which says x squared plus xy plus y squared equals to 13. Then we have x squared plus xy plus y squared equals to 13. And we know x squared plus y squared is here, and the equivalence value is 20 plus xy equals to 13. But looking at this, I think something is mixing. Yeah. So here, if I take out 2, so this should reduce to 10. So hereby we have this as 10, and while xy equals to 13 minus 10. So xy equals to 3. And if this is equation 7, and the next thing we are going to do is, if we still consider from equation 6, so equation 6 says x squared plus y squared equals to 10. And this is sum of 2 square, which can be reduced to x plus y all square minus 2xy. This equals to 10. And we know xy is 3, and we can put it here. So y this is x plus y all raised to power 2 minus 2 dot, which is xy, 2 dot 3, that is to multiply by 3 equals to 10. So if we multiply 2 by 3, that is 6, then we transfer it to the other side. So here we have x plus y square minus, let's say, equals to 10 plus 6. And by taking, let's say here is x plus y all square equals to 16. Then you can take the root of both sides, and this will take plus or minus, and this reduced to x plus y equals to plus or minus 4, as 16 is a perfect square. And I will start this. But this one that we just got now as the equation star is going to take both positive and the negative. It's going to be x plus y equals to 4, or x plus y equals to minus 4. So we have not gotten any answer for this, and from here we can guess. But let's see how to do this. Consider from equation 7, and I will deal with the positive side first. So x plus y equals to 4, and if I make x the subject of the formula, or suppose, yeah, we're going to have x equals to 4 minus y, and we put it here. So I want to get y first, and by substituting it, we have x bracket, y bracket 4, so it should be 4 minus y equals to 3. So expanding, we have 4y minus y square equals to 3. Then we transfer 3 to this side, and here becomes um is going to becomes 4y minus y square minus equal to 0. And if you do the rearrangement and I multiply through by negative, so here becomes y square minus 4y plus 3 equal to 0. And you can factorize this using quadratic factorization, and this becomes y minus y minus 1 is supposed to be 1, and y, so it's going to be negative. So when you do this, so we have y minus 3 equal to 0. So which means y equals to 1 or y equals to 3 as the two solution for y. So then let's see x. So since x equals to 4 minus y, then at y equals to 1, we are going to have 4 minus y. So if y equals to 1, then x equals to 3. And if y equals to 3, definitely x is going to be equals to 1. So this x equals to 3, y equals to 1, and x equals to um yeah. So I think I still make something here. It's going to be x, and if x equals to 1, y equals to 3. But here is not only the solution. So since the equation has a quartic values, so we only got the two value for x and y. So let's see the other part, which is when x plus y equals to negative 4. And if you still make y the subject here, so I want to get x first. So now I put this one in the equation xy equals to 3. So if I put it in this, that is anywhere we see y, we replace it with what we have as negative 4 minus x equal to 3. So expanding this, we have negative 4x, or let me say negative x squared minus 4x equals to 0. And multiplying negative throughout, we have x squared plus 4x plus 3 equal to 0. So, and trying to factorize this thing as well, we have this as x plus 1 and x plus 3. This equal to 0. So x equals to negative 1 or x equals to negative 3. So that is what we will get for this. And since this is another 2 by value for x, so we can get y here as negative 3 or negative 1. So when we plug it in the this equation star, so then you can combine this as a coordinate. So we have 3 comma 1, 1 comma 3, minus 1 comma minus 3, and minus 3 comma minus 1. And this is how to solve this problem. I hope you learned something today. So the question look a bit long, but I think there is a value there. If you have another way of doing this, you can drop it and subscribe to this channel. Never stop learning.